parallax effect details how when viewed from a changing perspective, objects will appear to change in size, velocity, and position based on their distance from the viewer. Like lots of topics we've covered in this class, parallax is implicit in how humans perceive the natural world, but must be simulated in graphics. This is an example of simulated parallax. The lighter blue buildings appear further away than the darker blue buildings because of how they move more slowly relative to the camera. For our final project, we implemented parallax rendering to our object loader. This applies the same principle as seen here, but on a per pixel level with respect to lighting. In this model of a bumpy surface, represented by the red line, A represents the actual position of the texel on a 2D surface. Using a height map texture, we are able to effectively reposition the texel to B, the simulated surface of the texture, so as to change the position of the object we are viewing and alter the distance from the camera. This effect creates a higher level of detail in lighting for a more realistically lit surface. To test our code, we found a model of a brick wall that came equipped with both height map and normal textures. We implemented the parallax effect on top of our already built model renderer, using normal mapping and this new strategy for a higher level of detail.
So this is the frag file, and here we specify a number of minimum and maximum depth layers that can be perceived on a single pixel. The number of layers changes based on the angle at which the pixel is viewed, with the minimum number of layers being achieved while looking at a pixel straight on. At this angle, there isn't much visible depth, and so we can save on computation. We calculate the number of layers by taking the dot product of view direction and the positive z direction. With the correct number of layers, we can calculate the exact amount to shift the pixel's coordinates. We then descend the layers of the height map, shifting the pixel's coordinates by the previously calculated value on each iteration of the loop. And as you can see, this is a method that we put all this stuff in. And in the main, as we are familiar by through the class, when all is said and done, we can simply apply this formula as another layer of frag's main function.